हेलो एवरीवन। आई होप आप लोग अच्छे हो, क्वेश्चंस प्रैक्टिस कर रहे हो एंड न्यू कॉन्सेप्ट्स यू आर रीडिंग. दिस क्वेश्चन इज रियली गोइंग टू टीच यू समथिंग new if you have not come across this thing. So let's start with the question. A parallel plate capacitor has two plates. So let's say these are two plates, plate A and I mean, let's call it plate A and plate B, but there is no need of it. Actually, these two plates are having area what A, and they are separated by distance D. So this separation is given. Area is A, and if there is nothing in between, that is air. If that is the case, then capacitance will be equal to how much? Epsilon naught A by D. Epsilon naught indicates that there is air media in between plates. Done it? Or you can say vacuum because epsilon naught is permittivity in the vacuum, right? The capacitor is charged to a potential difference of V and battery is disconnected. So what we are doing, we are connecting it first with a battery of potential difference V. Okay? And in that case, it will get charged, right? What will be the charge on this one? So its capacitance is C, charge that it will receive is CV. So one plate will receive positive charge plus Q and another will receive the same amount of negative charge, right? So this will happen like this. And after that, what we are doing, we are basically removing this battery connection after the capacitor is getting charged. So something like this is happening. Done it? And after that, what we are doing, a metal plate with area A and thickness d by 2. So we are inserting metal plate and that metal plate has area same as the area of these two plates. So this area is same and thickness is, I mean, not same as this separation, rather half of it. That is d by 2. Okay? And this is getting fully inserted between the plates so that it always remains parallel to the plates. So it is getting inserted somewhat like this. Okay? ऐसे है, and this is getting inserted like this. Calculate the work done on the metal slab while it was inserted. Done it? So we really carefully need to look at what will happen if you are going to insert metallic things in between the space of plates of capacitor. So capacitor का plate यहाँ पे दिख रहा है ना, एक के पास positive charge है, एक के पास negative. There is electric field, right? So if there is electric field in this region, then this question reduces like कि एक region में electric field है and in that region you are pushing or you are dropping or letting go a metallic structure like this into it in this way, right? So क्या होगा अगर एक electric field region में आप metals को ला रहे हो, then what happens? You already know that since metal being conductor, it has free charges, right? So it has free positive charge and free negative charge. Positive charge will start getting accumulated towards the direction of electric field and negative charge opposite to the direction of electric field, right? So some sort of polarization will happen within that metallic space. And since this is metal, it has enough amount of free charges such that internal electric field getting generated because of this polarization will be equal to external field, and that makes it possible that finally when it will be inside electric field, there won't be any electric field passing through this metallic space. That is, inside this metallic space there won't be any electric field. Okay? So it will simply rule out all the electric field. डन है एंड इट विल लुक लाइक दिस. सो यहाँ पे देखो ये नेगेटिव चार्ज इस पे अक्यूमुलेट हुआ है एंड ऑन दिस पॉजिटिव. दैट ऑल्सो जस्टिफाइज इलेक्ट्रिक फील्ड ड्रॉन लाइक दिस, क्योंकि ये इलेक्ट्रिक फील्ड कैपेसिटर के पॉजिटिव चार्ज से निकला. इट इज एंडिंग ऑन द नेगेटिव इंड्यूस चार्ज एंड आफ्टर दैट in this space there is no field and again it is starting from this positive surface, induced positive surface, and this is ending on negative plate of the capacitor. Something like this will happen. डन है. सो हमें क्या दिख रहा है? हमें ये दिख रहा है कि इनिशियली व्हेन देयर वाज नो मेटल प्लेट इंसर्टेड बिटवीन द प्लेट्स ऑफ कैपेसिटर, इन होल स्पेस डी देयर वाज इलेक्ट्रिक फील्ड, right? And done in whole space D there was electric field. Now what is the case? In whole space there is no electric field, rather in this space there is electric field. There is a region where there is no electric field, again in this region there is electric field. Such sort of case will be there. Done it? Now if you think here, what will be the dialectic of this metal? I mean, we can think of this in that way also. So what will be its dialectic constant for conductor? So if you remember how we write dielectric constant in terms of electric field, आपको याद होगा dielectric constant is written as external electric field that was I mean initial electric field, you can say, divided by the new electric field that you are getting because of the presence of dielectric. Let's say here this conduct dielectric meaning insulator, but conductor is basically not insulator, it is a conductor. But for this conductor, if we try to find out the constant, this dielectric constant, then E naught by E आप लिखोगे, and because of presence of this conductor, electric field is zero inside, right? So this will become zero, K will become infinite. राइट सो कुछ ऐसा हो रहा है इस क्वेश्चन में. नाउ वी नीड टू answer for calculate the work done on the metal slab while it was inserted. So while you are trying to insert it, I mean, will it be a natural process or will it be a forced process? जैसे आपने एक बॉल को पकड़ा and you're just dropping it. So it's a natural process because the moment you drop it, you don't need to do any work in order to bring it down to the ground. Rather, gravity will be there to assist you in that process, right? So you don't need to work in that case. यहाँ पे भी देखो डायलेक्ट्रिक को अगर आप इस स्पेस में ऐसे डालना चाहते हो ना, you don't need to actually do work. And why? Because see here, this was having positive charge, this was having negative charge. Electric field was in this direction, is in this direction here, and because of this electric field, negative charge is getting induced here, positive charge is getting induced here, and this negative charge layer is getting attracted by this capacitor's positive charge, and this positive is getting attracted by this negative capacitor plate. So basically this metallic thing is getting attracted inside the capacitor, we would say. Okay? And just like you drop a ball and it accelerates until it reaches to the ground, है ना, ड्रॉपिंग कर रहे हो, velocity 0 है, and when it's reached to the ground it has certain velocity, so it has accelerated because of acceleration due to gravity. Similarly, अगर आपके पास ये metal, I mean एक capacitor था and metal plate was here and you are dropping it. So if you are letting it go with a speed equal to 0, it will accelerate into the space of this capacitor. Done it? But if you have to take it slowly inside, in that case you need to do work. जैसे इस बॉल को अगर आपको slowly slowly यहाँ तक पहुंचाना है, कहने का मतलब without letting it get accelerated, in that case force equal to mg you need to apply upward. So here also you need to apply some force in the upward sense because it is getting naturally attracted into the space of capacitor. ठीक है, so यहाँ पे आप वर्क करोगे. So this metallic thing is getting pushed inward, right? And for that, to let it go inside slowly, we are doing some work, and this work will be negative because its displacement is down, force getting applied is up, because naturally it is getting pushed inside. Done it? And to not let it accelerate, we need to apply force in the upward direction. अब ये मैं क्यों कह रही हूँ, क्योंकि देखो हमारे क्वेश्चन में एक्सेलरेशन की बात कहीं नहीं हुई है. I mean, we are not provided with initially it will have kinetic energy or something like that. Done it? So we simply need to talk about potential energy here. Done it? And that is why I'm telling ki some external force must be applied in order to let it go inside slowly and slowly and slowly. So अब आप देखो क्वेश्चन क्या कहा था, कैलकुलेट द वर्क डन ऑन द मेटल स्लैब while it was inserted. तो क्या वर्क डन करेंगे हम? So for that we need to check ki what is the change in energy of this system. Initially, this capacitor is like this. It has a plus Q charge and it has a minus Q charge. Capacitance here is C and C is equal to epsilon naught A by D. So initial energy अगर आप लिखो ना, तो आप क्या लिखोगे? आप लिखोगे half CV square. ठीक है, या फिर आप इसको क्या लिखोगे? Q square by 2C sort of. Done it? So this thing you can write either this or this. Done it? And after the insertion of dielectric, how this energy is going to get affected. So after you have inserted dielectric, there is electric field in this region. There is electric field in this region. This region is a conducting region. So this cannot act as a capacitor. जैसे यहाँ पे positive charge था, यहाँ negative. Here there is negative charge and here there is positive. ठीक है? We cannot treat it like a capacitor. Done it? We cannot, because this is something sort of conducting space, and these charges are held here and here because of these electric fields in this region and in this region. Once you take it out, because it is a conductor, the charges will intermingle and you won't be getting any charge on this slab, right? But if you have some isolated capacitor thing, iske paas plus q charge hai, minus q charge hai, it will stay like that. It won't intermingle, right? Because there is insulator in between, so charge cannot travel from here to here. Done it? So that is why I'm telling, now the capacitor that you are left with is this one and this one, and is this one and this one. So you're left with two capacitor. One is this one, another is this one, and both are in series, right? Because whatever charge is here and here is here and here. I mean, जितना negative charge यहाँ induce हुआ है, same positive charge is induced here, and as much positive charge is here, that much negative charge is here. So overall, if you see on this plate, whatever positive charge is here is negative charge here, and so whatever is this plus q will be this minus q, and hence this is that plus q. So overall, we are getting two capacitors in series. And if you have little knowledge of when we insert any dielectric in between the plates of capacitor, and if dielectric or conductor here it is conductor, it is occupying a space d by 2. Left space is what? This is d by 4. This is d by 4. Then left portion, which is without any conductor, without any dielectric, its capacitance will be epsilon naught a by whatever separation is left. So d by 4 here, d by 4 here, d by 2. डायरेक्टली आप ऐसा लिख सकते हो. अगर ये आपको नहीं समझ में आ रहा तो आप दो कैपेसिटर को सीरीज में लिखो, ट्राई टू कंबाइन इट. सो C1 को मैं लिखती हूँ, दैट विल बी एप्सिलॉन नॉट ए by d by 4, right? And C2 will be how much? Epsilon naught a, same value, d by 4. These are in series, so you will combine them like in parallel. C equivalent क्या होगा? D by 4 epsilon naught A plus D by 4 epsilon naught A. So this will become 2 into that. So 2 into D by 4, that will become D by 2 by epsilon naught A. So C equivalent is how much? Epsilon naught A D by 2. That is what I told you, right? So ये कुछ ऐसा होगा, and इसको अगर आप compare करो C से, so this is 2 epsilon naught A by D. So this is becoming 2C. Now what is the energy? Final energy is how much? So initial energy मैंने बोला q square by 2c. q को आप c भी लिख सकते हो. Again that will give you half cv square. Final energy is how much? Again देखो मैं q क्यों ले रही हूँ, क्योंकि see potential might get affected because of this insertion of metallic space in between. Done it? Because electric field might get affected here. But what is not getting affected is whatever charge is present on the positive plate and whatever charge is present on the negative plate. But if plus q and minus q is not getting affected, then this electric field will also not get affected. But again, if you talk about potential difference, then that will become different, क्योंकि यहाँ पे इसके बीच आप potential difference देखोगे, E d by 4 लिखोगे. Here you will be calling it E d by 4. डन है. सो पोटेंशियल डिफरेंस इज गोइंग टू गेट अफेक्टेड समवॉट. इसलिए मैंने बोला एनर्जी के लिए आप क्यू वाला फॉर्मूला यूज करो, बिकॉज क्यू अफेक्ट नहीं होगा. रीजन being there is nothing to supply these two plates with charge. बैटरी हमने डिस्कनेक्ट कर दिया, सो कोई सोर्स नहीं है. सो दिस प्लस क्यू विल गो nowhere. It won't receive anything from anywhere, so it is going to stay plus q and it is going to stay minus q. So q is a constant here because system is isolated. Initial energy is this much. What you will write as final energy, charge को तो आप सेम रखोगे by 4c, right? So this will become, अब देखो यहाँ से change in energy आपको क्या मिल रहा है? q square by 4c minus q square by 2c. So this will become how much? Minus q square by 4c. So this is your final energy. I mean, this is energy change. And this energy change is negative. Done है? What does it mean? Simple meaning है energy घटा है, but क्यों? It means some negative work has happened on the system, and that is what I explained over here कि इसको अगर constant velocity से down ले जाना है, you need to do some negative work in order to nullify that acceleration effect, right? So actually we are doing here negative work, that is F into displacement by whatever distance it has gone down. So F dx, summation of F dx, right? This is the work, negative work we have done. And because of this negative work, energy of overall of this system has decreased. क्योंकि आप खुद सोचो कि अगर हमारे पास एक कार है, it is moving with v velocity, its kinetic energy is half mv square. If I am doing negative work on it, if I am doing work on it, applying force on it in this direction, it will do negative work on the car, and that is going to reduce its energy. So if final energy is has become lesser, it means negative work has happened on that system, and here that negative work is getting done by the external force factor. डन है. सो यहाँ पे ये इतना अमाउंट ऑफ वर्क हुआ है. हमसे क्वेश्चन क्या पूछा था, कैलकुलेट द वर्क डन मेटल स्लैब व्हाइल इट वाज इंसर्टेड. सो क्यू को आप ब्रेक कर दो. क्यू को अगर आप ब्रेक करोगे क्या लिखोगे, सी स्क्वायर वी स्क्वायर, क्योंकि क्यू इनिशियली क्या था, सी वी. And if V is given what? Yeah, V is given, right? So you will be writing as CV by 4C. So this will become how much? CV square by 4. C को भी आप break कर दो. Epsilon naught A by 4D, 4D V square with negative sign. So this is the amount, this is the loss in energy. This is the change in energy, you can say. अब चलो सेकेंड सेगमेंट की तरफ बढ़ते हैं. डज द टू प्लेट्स ऑफ कैपेसिटर अट्रैक्ट और रिपेल द मेटल प्लेट that is being inserted? So it is attracting, right? And because of this attraction only, energy has what? Decreased. ऐसे भी अगर आप बहुत ज्यादा वाइज हो ना, तो आपको ऐसे भी समझ में आ रहा होगा कि आप न्यूक्लियस की बात कर लो, इलेक्ट्रॉन की बात कर लो. Here both systems are in attractive zone, and that is why here energy is negative, right? So wherever attractive force is coming into account, energy of system is going to decrease. Here also same thing has happened. So you can explain it in various ways, but yeah, you should also look at this external force factor, because that is what is doing negative work here. ठीक है. सो या सेकंड का आंसर क्या होगा, दोनों के बीच में अट्रैक्शन है, रिपल्सन नहीं है. दैट्स द आंसर ऑब्टेन्ड इन पार्ट ए. हेल्प यू इन आंसरिंग दिस? यस, because in part A we are getting loss in energy negative, and this is only possible, I mean energy is decreasing, it means attractive force is in action. Simple. ठीक है. बिकॉज अट्रैक्टिव फोर्स होगा, सिस्टम को एक्सेलरेट करना चाहेगा, यू आर स्लोली टेकिंग इट डाउन, एंड इन दैट केस you will have to apply that external force such that work done on the system will be negative. So overall, this thing is happening over here. I hope you have understood this question, and I hope you are able to make sense of it. But if you have doubt anywhere in this section, you can always let me know. Because this question is quite conceptually loaded, I would say. So you may have doubt in certain portion, but if you have, you can always let me know. So thank you. Take care of yourself and keep on solving more number of questions. Bye bye. Take care.